Good morning once again, grade 12. This is a PET simulation for the electronics grade 12 2024. The name of this simulation is Inverting Op Amp. Then now, if you can quickly check the first component that is connected there in the inverting terminal or in the inverting input, it's Rin, that is 10 kilo ohm resistor. Then our feedback resistor there is 22 kilo ohms, the one that is used to control the gain of the operational amplifier. Then our supply is a dual supply, that is positive 9 volts and a negative 9 volts. Then we have a ground as well that is connected in pin number 3. Then now let's go to the equipment. We have equipment number 1, our function generator, that is adjusted to minus 1.5 volts to 1.5 volts peak to peak, and a frequency of 250 hertz. Then on the right hand side there we have our oscilloscope. Then we need to have two channels there, channel 1 and channel 2, to display our output. Then now before we go to the actual connection of the circuit, what you need to have for you to connect this circuit, you need two resistors, Rin and Rf, the 741 operational amplifier, then the function generator together with a power supply. Then we have our oscilloscope there. Then the voltage on the DC power supply must measure the 9 volts there and a positive 9 volts. So we use our multimeter to measure it. Then if you can quickly go to our DC supply with a 9 volts there, it's 9.0 or 9.1. Then we have 8.9. When you round off it, it's another 9 volts again. Then coming closer to our circuit, this is a simple circuit. If you look closer there, we have operational amplifier 741 op amp. Then we have Rin as 10 kilo ohms. Then we have the feedback resistor that is represented by red, orange there as our feedback resistor there. Then the positive VCC or the positive 9 volts is red, the negative 9 volts it's black. Then the ground there, it's green and yellow, that is the standard color code for South Africa. Then we're using our beautiful breadboard there. So if you can go to the function generator and look closely there, you have frequency of 250 hertz and a peak-to-peak voltage of 1.5 volts and minus 1.5 volts. That is our smart function generator. Then if you can see there, the channel 1 as the output is on there. Then let's go to our our oscilloscope. Then you see we have channel 1, channel 2, we have a scale there to adjust the time. Then we have the channel 1 and channel 2 to adjust the voltage per division. Then now, if you will remember, we said this is an inverting operational amplifier. That means the output will take the opposite shape of the input waveform, because it's being inverted, it's out of phase by 180 degrees. So let's go quickly and look at the output. If you can check on the oscilloscope there is 180 degrees out of phase. And if you see, the channel number 1 is a yellow one, that is our input, that is starting by increasing, decreasing. But if you check channel number 2 as our output, the one that we said it will be inverted, it will take an opposite shape. It's a blue one that is starting by decreasing, increasing, decreasing. So even if you can look closer there, we said that the PET document is saying the time must be 1 minute per sec. So 1 minute. Then the voltage per division, it must be 1 volts from both channel 1 and channel 2. So now even if you adjust the voltage per division in channel 1, you see your output changing, your input signal they're changing from a smaller to a bigger signal there. But what you must keep in mind is that both channel 1 and channel 2 must have the same number of voltage per division, 1 volt and 1 volt from both channel 1 and channel 2. Then again, if you can adjust channel number 2, you see now our voltage going, our output signal going up and down, or going big and slow there. So that is how you do your inverting op amp. Thank you so much. If you have a question, drop them in the comment section.